Hey, so we're going to describe the properties of water in terms of its intermolecular forces, and I thought I'd make this quick video because it's one of the highlights of the lessons that I actually teach chemistry myself. So the first thing that we're going to talk about is the surface tension of water. So surface tension is that really cool layer on the top of water, and if you've got really steady hands you can actually go and balance the needle on this, on the skin of the water. And it's actually quite good. I've heard of people that have been able to do a couple of needles. So if you've got a really steady hand, you can actually try doing that. So we also modify surface tension when we're washing our hands, when we're having a shower. So surface tension is a pretty important quality of water. And whether you believe me or not, those little pond animals, I'm sure you guys have been to the pond, and on the surface there, there's little insects that skim across the water. I think they're called water skimmers. And if you're feeling really mean, and look, I don't encourage you to do this because it's really mean, and I haven't done it myself, but they actually rely on the surface tension of water to stay afloat. And if you put a drop of detergent in, you can actually modify the surface tension, and they'll sink and drown. So now we're going to talk about surface tension and what it actually is. So surface tension is, like we said, that skin on top of the water, and I best describe this using a little chemist analogy that I came up with over my years of teaching. So just imagine that surface of the water. So say we've got a beaker of water here, and there's water filled up to here, and say at this surface, that surface of water there, there's a school playground or something. So think of a school playground in the afternoon when all the kids finish school, and usually I don't know about you guys nowadays, but when I was in when I was in primary school, even for that matter, we'd stay back and play after school, right, in the playground. So a lot of us would be in the playground, and mum and dad would be talking to a couple of other parents, and then they'd call us to go, and so off we'd run. We'd start going back, but then we'd messed up the numbers of the game. So the other kids would be like, hey, come back, you guys come back and play with us, and pretty much we'd turn around straight away and just go back to playing because mum and dad didn't have better things to do at that stage. And so much in the same way, water molecules and surface tension are exactly the same. So when you've got that really strong forces, we've already talked about hydrogen bonding and all that, but when we've got that surface interface and the water molecules want to leave and then go into the gaseous form, because you obviously know about evaporation and how water will evaporate over time, but why doesn't it happen straight away? So what's happening is that as the water molecule wants to leave, its orientation will determine in which all the other water molecules will come around it. So as it's leaving, he's kind of going up and that, and as that molecule's going up, all these other water molecules are coming around it and pulling it back down, and that constant pull, that leaving of molecules and then pulling back of those molecules is causing that surface tension on the top of the water. And I might just actually add that those water molecules don't just it's completely random, and every now and then one of those water molecules will gain enough energy to fly away from solution, right? It's not as if there are special chosen molecules that get sent up to wherever they're going, right? It's not like that. So every now and then a water molecule will just have enough energy to fly out of the water, and the other water molecules will come around, pull it back in, and that constant push-pull is causing that surface tension of water. Good. Now the other properties that I have to talk about, we already talked about boiling point and melting point, and I don't think we should, we have to talk about that any further. So, alright, good. And I'll write up the notes. You guys can continue to read the notes above for the last property. Good.